This is a short video about how to design more detailedly the metallization pattern in Griddler 2.5 Pro. So if you haven't seen this screen before, check out our earlier video about Griddler, which covers the basics of how to design an edge pattern. In the Pro version, one key difference is that you can independently define the wafer length and width. So for example, if we would like to do a half-cut cell, we would enter an aspect ratio of 2:1, and that gives us a wafer that's cut into half. If we want to do a third cut cell, we just key in a number which is a third of the width, and that gives us a piece of the wafer that's cut into 3. So if it were a monocrystalline wafer, then this would represent, the middle piece of the 3 sections. We can go to wafer type and choose, for example, a pseudo square. And we arrive at a wafer shape that's something like the top section of a 6-inch wafer that's cut into 3 pieces. So the interface is still easy to use but more flexible. For the time being, let's work with a full area uncut wafer again. Another expanded area of flexibility in design in Griddler Pro is in the shape of the bus bars. So here we have just straight bus bars. If we expand the drop-down list in style of bus bar, we get to choose between this straight and rectangular bus bar versus, let's say, rectangle pad tapered, and the corresponding shape is as shown here. So it illustrates a bus bar section that consists of the solder pad or the current extraction point, and then a trapezoidal tapered section. The maximum width of the bus bar is controlled by bus bar width. The length of the soldered pad is controlled by this parameter A, which is 2 millimeters right now. And the width of the trapezoid is controlled by the parameters B and C, which are 1 and 0.3 millimeters right now. And right now, this bus bar section is repeated 15 times because there are 15 solder or probe points. So if we make changes to these numbers, the pattern's updated instantaneously. And we can zoom in and have a look. Round pad tapered is slightly different, so the solder pad has a round ending, but otherwise the parameters are the same. Digital is also a kind of tapered, and the bus bar segment looks like this. You may have also seen segmented bus bars, so these are described by either what we call two-split, in which case the bus bar segment looks like the following, and here is repeated 8 times. You can also do 3-split, and then there will be 3 of these connecting sections. So maybe we reduce the width of these connecting sections a little bit. Busbar ending describes the shape of the busbar near the wafer edge. So straight actually simply means there's no particular ending, and the busbar section that we chose in the style section is just kind of repeated over and over 8 times. If we choose, for example, pointed, then near the wafer edge, the busbar shape takes on this arrow shape as defined by these 4 parameters A, B, C, and D. So now with these numbers, the end of the busbar looks something like this. And then there are other options to choose from. So digital again is more jagged. Apollo is just a name given by myself because it looks like the tip of a rocket. And then wine bottle is just a kind of round version of the same thing. So similarly on the rear side, if you had chosen H pattern, then you get the exact same options for the rear grid as the front in terms of how you would define the bus bar. If we're designing a monofacial cell with full area metal contact on the rear, then just like in the free version, we get to choose from different solder pad layouts. But here we get full control of the dimensions of the rear solder pads. Or we can have a round pad. Another place where you can design the grid more detailedly is tapered fingers. So for example, right now on the front side we have fingers that are 60 micron width. So each one of them would be simply rectangular in shape. Tapered fingers means to add a trapezoidal section in addition to this rectangle. So if we press it, let's say we taper from 120 microns over a distance of 1 centimeter. Now each finger takes on a shape like this. So this is a really stretched view of a finger. So now the finger contour is kind of tapering from 120 micron width down to 60 micron width over the length of 1 centimeter, after which it continues to run as a 60 micron line. So for screen design, this can be particularly useful, especially, if the screen finger opening is very narrow and we want to avoid finger breaks right near the bus bar. We might construct the fingers to have this kind of tapered structure. So I'm just going to finish off the design here, give it some typical parameters for the front and the rear grid. So now it looks something like this, with a certain maybe a pointed bus bar ending, segmented bus bar with 2 connectors. So all in all, something like this on the rear and this on the front. We can save this to AutoCAD. So the earlier Griddler video about H pattern designs actually shows you how to open the same pattern out in AutoCAD, edit it, and then import it back into Griddler. Or if you're happy with the design, you can go straight ahead and send the pattern off for print screen making. So now when we parse the front metallization pattern, we have the pointed bus bar ends and the segmented bus bar segments and the tapered fingers assimilated into the contour. Now, recall that in the Griddler video, we mentioned about the possibility to do some post-editing of the pattern, like creating an extra shape. So in Griddler 2.5 Pro, you're able to do that more precisely through the command. So by the way, there's a command for virtually every process you can do with the mouse in Griddler 2.5 Pro, and then more. So check out the video about how to use commands and scripts to make your workflow much faster. Here what we're concerned with is the draw extra front shape command. So as in the earlier Griddler video, suppose we want to draw this extra connecting line, right, in between the 2 bus bars, which bisects the bus bars. So let me just do a little quick Excel calculation of where that interconnecting line should be. So we go draw extra front shape. We want to draw it in the finger layer, and the coordinates are like so. Now we have ourselves this bisecting line. We can easily repeat the same thing on between the other 2 bus bars. So that's a more precise way to define these extra shapes. And then of course, if you want to be even more specific in customizing the pattern, you can do that in AutoCAD, as you have seen in the other Griddler video about designing an H pattern. So Griddler 2.5 Pro is a really professional designer for silicon wafer solar cell metallization screen design. It's fully compatible with AutoCAD, and then not to mention, you can always check your work at the end by simulating it. So it's really a design and simulation tool that gives you a lot of in-house capability.